So you see, the first one is wait. When you have a valid next hop for multiple paths, the neighbor with highest weight is a preferred path. If in case there is a tie, then neighbor with high local preference or a router with high local preference is preferred. The default weight is 0 and the default local preference is 100. And then if there is a tie in this, it will give preference to local originator, meaning it will provide more importance to the advertised network than a redistributed or summarized network. And then if there is a tie, then it will go to the shortest AS path. Sorry, this one, local origin, meaning the one with the next hop 0000 is given more importance. So when you do summarization, even the summary route will have next hop 0000. We'll do aggregation later and I'll show you this. Even the redistributed network will have next hop 0000. If it is so, then that is preferred. Then shortest AS path is preferred if there is a tie in above 3. And if the AS path is also a tie, then it comes to the origin type. Means the advertised network is preferred more than exterior gateway protocol, which is no more available. And then incomplete is the redistributed network. We have spoken about this thing earlier. And then compares the MED. It is only applicable if you have dual homing. Otherwise, it's of no use. And the one with the lower MED, the neighbor with who advertises with the lower MED is preferred. The default MED is 0. And then if you have multiple paths, one is EBGP path, another is IBGP path. EBGP path is going to be elected. If there is no EBGP, what does that mean? It means that both are IBGP. Sorry, both are IGPs. Means you're correct, both are IBGPs. If you have multiple paths with IBGP, then the path with low IGP metric, like low cost to reach one of the BGP here, the border, will be preferred. Now, if there is conflict, even if there is a tie in this, then it goes to the determines if multipath required installed in the routing table for BGP multipathing continues in the best path, not if best path is not selected, meaning to reach this IGP. If you have multiple paths locally, multiple paths not provided by BGP, this multipath is provided by your IGP path, local routing table. If your routing table shows multiple paths to reach one of the neighbor, it will use both. So this is not considered as BGP's multipath. With the support of IGP, and if you would have configured OK BGP, you can use the multipath only then. There is a command called multipath, BGP multipath or max path command. If I click, it will show me. See here, max path. Right? So only when those things are configured, that is possible. I do not want to get you there now. Let us go back to our flow. And now after this, if there is a tie in this, then it when both paths are external, see in the above two, both are IGPs, IBGPs, internal. If both are IBGP, IGP cast, the lower IGP cast is preferred. If you have multiple paths, if BGP multipath is configured as I showed here, max path command. Only then it will use multiple paths to reach that IBGP alone. As I showed you in the presentation in the previous class, BGP is not designed where it is. BGP is not designed to perform load balancing. It's an important point that you should always remember. BGP always selects one path out of multiple paths through iteration until single best path is left. So this is what the reality. You should not get confused when it says BGP multipath. This is within an organization, within an autonomous system to go to the border. If you will have multiple path, definitely you will have a full mesh topology. In that case, if IGP provides, if OSPF provides equal cost to reach both the IBGP members, and if BGP also configured with max path 2 or 3, whatever, only then it will use all those paths to reach the IBGP neighbor, up to that IBGP neighbor, not beyond that. Now, in case if both are EBGPs, then performs the path from where the route is received, the old route. See, if you have two neighbors, one neighbor might have given you route first, the other neighbor might have given a little bit later, maybe few milliseconds or few seconds or few minutes later. So the one who gave the route first, the neighbor from whom you received the route first, that's the neighbor to prefer. If assume that both reached at the same time, which is very rare, in that case, it will compare the router ID. Right, so the one with the bigger router ID will be preferred. Sorry, lowest router ID. Wait, yeah, correct. Lowest router ID is preferred. If in case, the very rare chance, two EBGP have got same router ID, what you will do? Same, sorry, if the originator or the router ID is same for multiple paths, prefers the paths with minimum cluster. See, this is only for route reflector. Otherwise, this point number 12 will not come. Nowadays, it's difficult to see many route reflectors because we got MPLS, MPBGP tunnels. If you don't have MPLS in your option, then you will have BGP solution called route reflector and confederation. When you have route reflector, each reflecting server will be considered as a cluster, and that router's ID will be considered as cluster ID. Prefers the path with the minimum cluster length. Yeah, cluster ID. The router reflector server's router ID is called cluster ID. So if you have many clusters, the cluster with the minimum length, one neighbor has got more length, another one has got. When we do router reflector, I'll show you this cluster length and all. So this is very rare case to see. Mostly this will be the tiebreaker. Next is prefers the path that comes from the lowest neighbor address. This is the final tiebreaker. Definitely one neighbor address will be different from the other. So one will be bigger than the other, one will be smaller than the other. The smallest neighbor, the lowest neighbor, like lowest route ID, here lowest neighbor address. That is the neighbor that will be preferred. So nowhere here you see community. But So if you see here, um, let me try to use this. Mhm. A community is just a numerical value that is to identify the group of prefixes which is going to be treated in the same way, common property. BGP community attribute is an optional transitive attribute of valuable length, means attribute consists of set of 4 octet value that specifies a community. 4 octet means 32 bit. While community themselves do not alter the BGP best path, look at this. Even though it is described as optional, non-transitive, all those words for a community, they are not going to alter the BGP path at all. Then it is not real attribute. It's not really it's not going to impact your best path. Community can be used as the tag. That's what I was saying again, tag. Used as a flag in order to mark a set of routes, means prefixes. Upstream service provider routers can then use the flag, use the marking, and apply some policy like local preference. All right. So community is not going to impact BGP path selection. Is it clear? Mm. Mm. I repeat again. It won't impact path selection just if you configure community. Community is only tagging. Then only there will be a impact in path. Only when you use attribute. So you can call the feature community as an optional, because maybe if it is present, I'll take decision X. If it is not present, I'm still going to accept the packet as the packet that needs to go via Y. So it is not going to drop the packet because there is no community variant. Not like that. You see? Let me repeat again the statements. BGP is optional transitive, meaning if it is not present also okay. If it is present also okay. Still the updates are valid. If community tag is there or not, the BGP update is still valid. If it is there, then the community tag may have some meaning for it, like local preference or something set. If it is not there also, still the packet is valid BGP update. It is not a non-transitive one, it is transitive one. Non-transitive means it will be discarded. That is why when you go inside, it shows it will not determine the path. It is not going to alter. Only when you use with local preference, this well-known attribute is going to determine the path. This local preference is a well-known attribute. That is going to determine the path. Or wait, or MED or anything you can use with community. Now let's go back to this one. In the previous class, we learned these things. Something is wrong with my, okay. Just now, we spoke about this in the other Cisco site. So this chapter was completely about the sequence in which the attributes are going to be effective. Now, to apply the attributes, we need to use route map. Not always, sometimes. If you're going to set attributes for some destination, not for all destinations, then you need to use a route map to say for these destinations, this is the route. For the rest, the default, something like that. So you need a route map. So we are going to see how a route map can be used to manipulate basic BGP paths. You see, we have two autonomous systems in this picture. Router A and router B has got some policies. Router A says I'll send utilizing 60% of bandwidth and I'll receive data is only up to 10% of bandwidth utilized. And B says for incoming I'll use 70% of my bandwidth. For the outgoing I'll only have 20% of bandwidth. How is this possible? For this you need to really do some big homework, meaning you need to study your network and see for what all destination 60% of bandwidth is needed. That you need to map to the upper path from A. For that you need to go to A and say this is the preferred router, so local preference is 200. Only for those destination to which 60% of bandwidth is needed. And then for those destinations where 20% bandwidth is needed, for those destinations I give 200 local preference on B. So now from A, when packet goes, it checks whether it is matching with that 60%. If yes, it will send via A out. Not only A router, any router, even the router inside, it wants to send some traffic. If the traffic that matches with A's 60%, then it will send the traffic this way. If it matches with B's 20%, then it will send it via B. That is how you can achieve this load sharing. Likewise, incoming. When the route update comes in, you need to say 75% of traffics are for XYZ network. So as the update comes in for XYZ, I'll give high preference here. And for the traffic that is consuming 10%, as the update comes in, like A, B network, I'll give high here. By doing so, I can impact both incoming as well as outgoing traffic. Yes. Both are same. In Cisco iOS router, we will call it as route map. In iOS XR, we call it as route policy language, RPL. Both are same. RPL is little bit easier than route map. RPL is more easier to use, more friendly than route map. We'll see RPL bit later, the differences, but if you know route map, it's the same approach. Slight variation in the commands. And more flexible features in RPL, like using regular expression and all, very easy there. See, without using route map, you can have attributes configured. Route map is needed only if you want to identify few networks out of many and provide some special policy. But if you have policy for all networks, then you don't need route map. You can simply go to the router and say this router's local preference is 200, meaning for all networks that is advertised into this router, which can be advertised by this router to other inside routers, this is the preferred exit. So there is no specific network mentioned here. This is for all networks in the routing table of this router. This is the preferred exit. There may be another router with same networks, but their local preference is default, which is 100. Here I have configured as 200. So what I want to say here is this is global. What? Yes, please tell me. Hmm. 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 Again, similar to what is the difference between route map and RPL. Basically, both does the same thing. RPL is more flexible than route map. Likewise, prefix list is more flexible than access list. In prefix list, I can use greater than or less than, range command. All those things are not that. It is possible to do in access list, but a little bit tricky. You need to add more commands, more wildcard mask. See, access list don't support subnet mask. You need to write wildcard mask, right? So those things may be difficult for you, but in the prefix list, you just put on /8/24. So more sophisticated access list is what prefix list is. Mm. 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 Say there. Maybe it is done by multiple engineers. Some are comfortable with access list, and whatever they need, they have put using access list. Some may be security engineers or some other engineers who are comfortable with prefix list. They might have done their configuration on the device using a prefix list. Or old employee left, new employee has come, new employee knows only access list. The old employee has got prefix list. That is why. See, otherwise, I can use only one. Or there may be one with one prefix list you may be using with the route maps. Access list you may be using as a normal access list to do some filtration on the physical interface, something like that. Again, it's not that mandatory to use only physics prefix list or only access list. You can use both like this, or if you are comfortable to use any one of this, that is also well and good. Yes, yes, yes. No, 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 that is also access list. See, policy can be applied on the interface level, on the global level, or CPP control plane policing for under the processor level. So policy is policy. You can write access lists and do that. You can also use class map and policy map and do that. So both are policy. Whether you write access list or class map and policy map in firewall, both are policy only, providing you the facility to achieve the policy. Local preference is globally configured here, not for a specific prefix. Now this is a small case study. I want you to really focus close to this picture, to this topology here. There is a network called 172.16.0.0, which is like 1-2 hop. And there is a network called 172.30.0.0, which is 3 hop this side. But if you go this side, it is 1 and 2 hop. And there is a network called 172.24.0.0, which is 1 hop via Y. Yep. So these are all the 3 networks. For example, we are taking 3 destinations, 3 networks. So according to me, going to this network, let's say alpha, going to this alpha via X is 1-2 hop, via Y is 1-2-3 hop. So Y X is preferred according to me. It is not router, it is autonomous system. BGP is autonomous system. You see, to reach this network, to reach this network, this autonomous system should take X exit, not Y. If it takes Y, it is long route. You agree, no? Yeah, this is according to our thinking. According to AS path, we think. According to the number of hops, we think. And to reach 170 to 30, exiting via Y is better. For alpha, we want to come via X. For beta, we want to come via Y. And for gamma, we want to come via Y because it's only one hop. This is our thinking. According to the hop count, we'll have this as a policy. We'll have this as a policy. We'll go here and say match 172 24. 172 24. Local preference 200. Likewise match 172 30. 200, isn't it? And we'll go to A and say match 172 16. Local preference 200. This is how we will say to achieve this. But this may not be your expectation. Your expectation is as per the bandwidth utilization. See, if it is hop count, this is how we will do. But what if your expectation is to do load sharing? For that, you have already done a study of network. You found that 30% of traffic is 172.24. Where is 24? Here. 30% of traffic needs to come here. And 20% of traffic is for this destination. And 10% of traffic is for this destination. Please understand here, according to what we have discussed, we are going to use 50% of traffic via Y and only 10% of traffic will go via X. Do you agree? No. According to what we have discussed as per the hop count, to reach 170 to 16, which direction you go? Via X. Now, what is the percentage of traffic that is going to 170 to 16? Only 10. The other two networks, 170 to 30 and 170 to 24, what we spoke earlier is we decided to send it via Y. Correct or not? What is the percentage of traffic? So, when we think in the hop count perspective, we are pressurizing more Y and very less pressure on X. And if you want to do load balance, what you need to do is you need to give this 20 to X, isn't it? If you give 20 to X, then both sides it is 30%. Both sides. For that, what you will do? You will match this prefix and you will give high local preference 200. Correct. For that, you will write an access list or prefix list on router A. Match this 172.30. Call it under the route map. Set local preference higher. And bind it with this neighbor as the neighbor advertises in. When the update comes in, you will add high local preference. That's all. You see, that is what they are going to do. Initially, if you see, as we spoke, according to the AS path, this is less AS. For 170 to 16, it is going via 28. You know who is 28? 28 is X. This is X, this is y. This is y. This is x. This is y. This is x. And if you see via y, only one network is going. Sorry, via y, two networks are going. And via x, there is only one network going, which is 20, 16, which is only 10%. You understand? So via y, you can see there are 50% of traffic going, and via x, there is only 10% going. So what we do is we go to router A. Where is router A? Router A is here. We need to now match this in the access list. See, that's what they are doing. And call the access list under the route map and give a high local preference. For the rest of the traffic, no change. That will be as per the hop count. And now call the route map with this eBGP neighbor. See, 28.1 is an eBGP neighbor. Yeah. And you say when the eBGP neighbor advertises the networks, if the network matches with this, then the preference is 400. See, as the update comes in from eBGP neighbor, we take an action. This we bind it where? With a neighbor statement under BGP. Is this clear? After doing that, you can see earlier 170.30 was going via 50.1. Via 50.1, the 20% now shifted to 28.1. Yeah, that's it. This is just one small case study. Even though the number of hops are more, before AS path comes local preference. Yes, before AS path is a local preference. Let me show you. You see, before AS path is local preference. So if there is a change in local preference, the tie will break here. AS path will come into picture only when there is tie in the above 3. Is this clear? Now MED can be configured globally like this, or you can also use it with the route map like you saw in the previous example. MED is nothing but multi-exit discriminator. When you have multiple paths to an autonomous system and you want to prefer one gateway over the other, you can set the lowest value. The default is 0. You can go to the other one which you don't like and give high weightage, a high MED metric. Metric is the keyword command to match MED values. MED is used when multiple paths exist between two autonomous systems. So the lower MED value, the neighbor who advertises the network with lower MED will be the preferred eBGP neighbor. So this is only between eBGPs. So the lowest MED value is preferred. The neighbor who advertises the network with the lower MED is going to be preferred. MED is an optional, non-transitive. So you must see MED. If it is not seen, at least 0 should be seen. If it is not seen, the update will not be accepted, will be rejected. Usually, MID is shared only between two autonomous systems that have got multiple eBGP connection with each other. This is the command to change the MID globally. As I said earlier, you can also use along with the route map, instead of saying set local preference, you can say set metric. You can use MID. MID is considered as the metric of BGP. All the routes that are advertised to an eBGP neighbor are set to the value specified by using this command. Any question? It can be like that. You see, between two autonomous systems back to back, you got multiple connections. It may be like this also, or it may be like this also. Yeah, two connections between two autonomous systems. So usually we will have three autonomous systems when you have two connections. Usually we'll have one connection to one ISP, another connection to another ISP. That is not dual homing, that is multi-homing. Here, the upstream is only one ISP. This is dual homing. Two connections to the same ISP is dual homing. Mostly when people have got multiple connections, they will not be connecting to same ISP. They will be connecting to two separate different ISPs. Correct. There MID will not work. MID will work only if you have like this. This is autonomous system. Yeah, correct. See, MID is shared only between two autonomous systems that have got multiple eBGP connection with each other. So here is an example how to use MID with route map. Similar to what you saw in the local preference, you are going to use MID. Here, this is only between eBGP. You here sitting prefer, let me see, you are an ISP. Okay, this is an ISP. This ISP wants to prefer 25 and 26 to come this way. You understand? And 24 don't want to prefer, that's why big number. Whereas here 24 is preferred. 24, anyone wants to go to 24 will only go via Y. 24 will go via Y because X is advertising. Because this arrow mark is that, don't think it is configured on B. No. This is configured on Y. And this is configured on X. So X will, sorry. This is configured on B, this is configured on A, and the path is going from, packet is going from XYZ. Let me repeat. This is configured on A, and this is configured on B. And Y learns that going via this interface is the best to reach 24 because 100. You may have a link like this. Y says, I will not go via this link to X because 24, sorry, for 25, 26, I'll go via this way. Because for 25, 26, this is the best way. See, a few things may confuse you here, but if you focus, no, even in Iowa itself, I can make it clear. I'll do lab also, but you see, it's not difficult. Needs some explanation, that's all. You see, router A says 100 to 25 and 26. Router B says 100 only to 25. Smaller is preferred. So according to X and Y, they know that we need to exit via Y for 24 network, and we need to exit via X for 25 and 26 network. But how Y knows that X is the best one to reach 25 and 26? It is through one wire here, which is not shown in this picture. You see, even though this is advertised between EBGP, even though it is advertised between EBGP, that will reflect to one hop here. So that X will know that Y is the best one for 24 and Y will know that X is the best for 25, 26. You understood this point? So those things were not explained in the pages before, not in this picture, but only when you do practical, you'll see that. MED is advertised between EBGP, no doubt, between autonomous system. And this is also true whatever X learned as MED will also be known to Y if you have a IBGP neighbor. And Y will be advertising to X as an IBGP neighbor. Z also will know. But after Z, if you have some other router, they will not know. So this is how you configure. You see these two networks, 25 and 26. 25 and 26, we give 100. And for the rest, you don't need to write an access list. For the rest, we give 200 on router A. And we call the route map, and we are saying out. We are saying when you advertise this network out, put 100 for this two, and the rest means it is 24 only, according to us. All the rest of the network is going to have 200. On B, it is opposite. Only for 24 you give 100, for all the rest it is 200. That's all. This is the output on Z router. You see, I told you Z router can show you the metrics. Even though it is between EBGP it is given, it will reflect to one hop inside EBGP. Inside IBGP. The Z router can show you. Z says I'll go via 50.2, which is Y for network 24, and for network 25 and 26 I'll go via 28.2, which is 28.2, which is X. 25 is correct. Yep. So it is achieved. Right, these are the things that we should do as a lab. Like we need to do one lab with the local preference, one lab with MED, and we'll have a little bit different case study. Not exactly the same also you can do. Right, that's it. So this is about BGP attribute configuration with route map. And then the last, no, there are two more chapters. No, this is the fifth one. There's one more chapter left. Sixth chapter. I don't think it's a chapter, it's just a summary. Let's see. Yeah, it's just a summary. That's it. All right. So what is not explained in this presentation is the community, which we'll be seeing separately, and the route reflectors and confederations. but not used in the production. Configurations are not used in production. Route reflector will be seen with MPLS tunnels sometime. So we have to focus on those things. Before that, let us finish these labs that we spoke.